Hello, our base number is item 4, 2025 UCE Mathematics. It says that your school employed a new mathematics teacher to improve on the performance of mathematics students in senior 4. In order to improve on the performance of senior 4 students on the side of mathematics. First of all, they are saying that before employing the new teacher, the performance of the learners, their mean score was 54%. Then 38% of the learners are below the passing mark, which means 38% of the total number of students. They used to perform below the passing mark, which is 55%. Then they gave us this graph as the histogram showing the performance of the new performance. After employing the new teacher, this is the performance that is represented on this histogram. Then the school is in need of analyzing this information that is on this graph to see whether the new teacher brought the new teacher improved the performance or brought an improvement in the performance of the students on the side of mathematics. So our goal is to draw a weighted frequency distribution table from this histogram. Remember, histogram, the x-axis contains the class boundaries, even the y-axis contains the frequency. So my goal is to get these class boundaries from this histogram. As you are seeing, the first bar is from 14 to 24.5.5, which is this one. It is corresponding with 15 as the frequency, which is here. Then the second bar is from 24.5 to 34.5, which is this. It is corresponding with 30, which is here. So you go on like that up to the last frequency. Then, according to the question, they want us to calculate the mean score at the same time to find how many students are below the passing mark, which means on my table, I need the x, I need fx, I don't need to measure the frequency because I'm not going to use it anywhere. Same applies to the x squared. I'm not going to use them. So I'm going to just use x and fx. The classes I'm going to get them from here. Remember, we get class boundaries from classes by subtracting the 0.5 on the lower class boundaries and adding the 0.5 on the upper. So for now I'm reversing, which means I'm going to add this side, I subtract this side. So let us do it together. This one, if I add 0.5, I get 15. 15, this is 24. Then this is 25, this is 34. This is 35, this is 44, this is 45, this is 54. This is 55, this is 64, this is 65, this is 74, 75, this is 84, and this is 85. And the last one is 90, is 94. So this is our class. We obtain it from the class boundary. Then I'm going to go on to get the x. Remember, x is the middle number of these classes. I'm going to get this plus this, I divide by 2. It's the same as getting 15 plus 24 divided by 2. If I do so, my first x is going to be 19.5. If I get 24 plus 15, which is 39, divided by 2, I get 19.5. So, since my class interval is the same, it is a difference of 10. There is no me of going on to getting x on each and every class. If I get the first x, I just go on adding the 10 as the class interval. So 19 plus 10 is the 29.5, 39.5, 49.5, 59.5, 69.5, 79.5, and 89.5. So those are my values of x. Then I'm going to go on to compute the value of fx by multiplying f, which is the frequency, times the x that I have obtained. But the problem on this number, once you make any error, all number goes. So therefore you need to place your calculators when you are keen. that you are not going to make any mistake. So let us compute them. If I have 15 times 19.5, I get 292.5. Then here I get 885. Then 10 times this, it is automatic, is 395. The point just disappear. Then 45 times 49.5, I get 222.7.5. They are 3 twos. Then 90 times 59.5, I get 5355, which is 5,355. 50 times 69.5, you get 3475. Then 30 times 79.5, you get 2385, and 5 times 89.5, you get 447.5. So those are the values that we are having after placing our calculators. Then to calculate the mean, I need the summation of fx and the summation of f. Let us add this f. If you add them using your calculator, the answer is what? It is 275. 275 is the summation of this f. Then let us get the summation of fx. It is 462.5, which is 15,462.5. It is the summation of fx. Then the school wants to analyze this data to see whether the new teacher made an improvement. Is it true that the new teacher made an improvement or not? We need to calculate the mean score. The mean equals a summation fx over a summation f. A summation fx is 1546.2.5 over 275. Let us place our calculators and raise our answer. We get 56.23. We have 56.23. So this is our mean. But we need to compute this mean in terms of percentage as the one that we are having in the question. Then we are going to calculate the percentage mean score. The percentage, let me just use the sign of percentage. The percentage mean score. It is what in terms of formula? It is the same as the mean over what? It is over the maximum possible score. It is over the maximum possible score. Then all of this one times 100. Times 100. I'm going to get the value of mean, which is this one, over the maximum possible score. Then according to our class, the maximum is 94. Then the maximum possible score is this 94 plus 1. So this one, it gives me mean is 56.23 over the maximum possible score, which is 94 plus 1. Then all of it times 100, which means the maximum possible score here is 94. If I get this divided by this, then times 100. Which answer can I obtain? It is 59.19. is 59.19, which is approximately 59%, which means the new percentage mean score, it is 59%. Remember the old one was 54%. So which means the teacher has made an improvement in terms of performance. Then you will also get the number of percentage, the percentage number of learners who scored below the pass mark of 55. According to our class, 55 is here. So which means these 90 students and these ones, all of them are about 55. So the number below 55 is from 45 and above. Those are the students who scored below 45 as the passing mark. So I'm going to get the percentage of learners below the passing mark. It is going to be the sum of these numbers from 45 and above who are below this 55. It is going to be 45 plus 10 plus 30 plus 15 over the total number of students, which is 275. 275. Then I multiply it times 100. If you compute, which answer are we obtaining? Let us first add this one. This plus this, it is 60. Then this is a 40, which means the total is 100. So I get 100. Then this 100 times this 100, I get 10,000 over 275. If you compute using your calculators, what is the answer? It is 60, it is 36.4, which is approximately 36%, which means the number of students below passing mark, it is 36%. Remember the only percentage is 38, which means the number of students below passing mark has reduced by 2%. In conclusion, the school improved in terms of performance on the side of students in mathematics as a subject after employing the new teacher. Therefore, the percentage of learners who scored below 55% reduced by 2%. Even the percentage mean score, it is 959. The old one was 54, which means the percentage mean score increased by 5%. Therefore, the school has made an achievement. Thank you for watching. Math is easy for us.